Okay, we're going to look at the ways in which the ways in which you can make an amine. The first one we've come across briefly in year 12. You've got a haloalkane, and you react it with ammonia, which is of course a good nucleophile. You've got a delta positive on this carbon, and you get the primary amine, and you get hydrogen bromide as well. The second way is the reduction of a nitrile. Here's a nitrile. And if you remember, you make a nitrile, well, you usually make that by nucleophilic substitution of a haloalkane with cyanide, and then you reduce it and you get the primary amine. Okay, let's have a look at the nucleophilic substitution reaction first. Okay. Right, let's start off with bromoethane. I'll write that like this. Right, and it reacts with ammonia, which I'll do in a different color. Okay, we've got delta positive on the carbon there. The lone pair on the ammonia is going to move onto the carbon. The bromine is going to drop off. So you end up with this. Now the nitrogen is still forming four. It's still got three hydrogens. It's forming four bonds, so it's going to have a positive charge on it. And then the hydrogen drops off, so the pair of electrons in the nitrogen hydrogen bond go back to the nitrogen, go back to being a lone pair essentially. And really, you should, because you don't really get a proton, it will be picked up by another ammonia in the solution, and it will form NH4+. But we don't need to draw that. It's perfectly okay to just draw this in the mechanism. So we get CH3, get the primary amine, CH2, NH2. But that isn't the end of the story, because this lone pair, this species is a good nucleophile because it's got a lone pair and a nitrogen there. So that can react again with another molecule of bromoethane. So I'll draw the next bromoethane molecule in a different color. So let's do that in green. Right, so that lone pair is going to attack this carbon. The bromine drops off, and we're going to form this species. So we've got our nitrogen still attached to two hydrogens, and it's got a second alkyl group on it now. And of course, it will be a positive charge on that nitrogen. Positive charge on it. Okay, it's forming four bonds, and once more we're going to lose the hydrogen. The electron's going to go back into the nitrogen. So the product we're going to form is the secondary amine. Okay, but of course that isn't the end of the story either, because you've still got a lone pair on this nitrogen. So that can then react with a third molecule of haloalkane. So let's draw that one a different color again. Now, and that pair of electrons is going to go onto the carbon there, and the bromine is going to break off. Now, I'm not going to draw all the steps out again, but because I'm sure you can see what's happening. But let's see what will happen then. Is we will form, do that to show there's a couple of steps involved. You're going to form a tertiary amine. So we've got the black ethyl group, the nitrogen, the green ethyl group, and the third one we stuck on, the purple one. But that isn't the end of the story either, because now what we've got is we've got a lone pair on the nitrogen, which can again act as a nucleophile. So let's draw a third fourth alkyl group. So here's your bromoethane, in another molecule of bromoethane, and that is going to attack that carbon. The bromine is going to drop off again. I won't draw all the steps once more, but you're going to get this, the nitrogen with, and I won't draw them all in different colors this time. I'll just put CH3, CH2 4 times, and hopefully you can see that the nitrogen there is going to have a positive charge on it. Okay, so now let's see what all of those things are we can get. So we can get this product. Oops, okay, maybe I'll do it like this. We could get this product, which is a primary amine. We can get this product, which is a secondary amine. We can get this one, which is a tertiary amine. And this one here, the last one, is called a quaternary ammonium salt. That's quaternary ammonium salt. And that would have to have a negative ion to go with it, in this case, because it would be Br minus. Okay. Right, so that is undesirable, obviously, because you're going to get a mixture of 4 different products. But you can probably guess how we're going to, if you wanted to not get the quaternary, if you wanted to just stick at the primary amine, well, you've got to make sure you don't have too much bromoalkane around. So you have a large excess of ammonia and not much bromoalkane, and you'll end up getting the primary amine. If, on the other hand, you want the quaternary ammonium salt, you will need lots of haloalkane, so you have an excess of haloalkane rather than an excess of the ammonia. And they very frequently ask that question: how would you ensure that? What are the conditions to ensure you'll get a primary amine? Or what are the conditions to ensure you'll get a quaternary ammonium salt? So let's just summarize that. Okay, so product, black, I think. So product and conditions. So if you want the primary amine, or if you want the quaternary ammonium salt. Right, for the primary amine, you're going to use excess ammonia. For the quaternary ammonium salt, you would use excess haloalkane. Okay. Right, let's talk about the second way of making them, which is by using reduction of a nitrile. Okay, so draw a line under that. So reduction of a nitrile. Right, so just to remind you that you make a nitrile by, say we start off with bromoethane, react that with KCN, and you might remember that it needs to be in ethanol and water, and they insist on you write in ethanol and water. If you don't do that, you don't get the mark for the conditions, and it's got to be KCN. You'll end up with the propane nitrile. Now, what you've done is you've lengthened the carbon chain by 1, and that's pretty important to be able to do that. So you lengthen the carbon chain, and then you reduce that with lithium aluminium hydride in ether. That's the reducing agent, and you will get CH2 CH2 NH2. So what you're essentially doing is you're sticking 2 hydrogens onto that carbon, and you're sticking 2 hydrogens onto the nitrogen. And okay, right, let's just talk very briefly about the reducing agent. This stuff, lithium aluminium hydride, is very similar to sodium borohydride. So if I just compare the two there, lithium aluminium hydride, sodium borohydride, but lithium aluminium hydride is stronger, right? They're both they're both group 1 metals. Okay, they're both, so that's going to be Na plus, and that's going to be BH4 minus ion. This is going to be the Li plus ion and the AlH4 minus ion. Al and Br, Al and boron are both in group 3 of the periodic table. They've got 3 electrons in their outer shell, so they're very similar compounds, but this one is stronger. It doesn't work. Sodium borohydride will not work for this step here. There is an alternative there, unfortunately, because it's just something else to remember. You could also use the hydrogen gas with a nickel catalyst. That is another reducing agent which will work in that step, but borohydride won't work. Right, so a fairly common question would be, we've got 2 different ways of making, let's say we want to make the stuff we just made there, propylamine synthesis. There's 2 ways we could do it. One, we could do we'd start off with bromoethane and react it with KCN, and that would form the nitrile. And then we can reduce the nitrile to propylamine. So you need lithium aluminium hydride there. The second way you could do, right, you could start off with bromopropane this time and react it directly with ammonia, and then you get the same product. And what are the advantages and disadvantages of the two different methods? Well, the disadvantage of this one, number one, is this one has got 2 steps. There's 2 steps, so you will get a lower yield. So each reaction you do, you never get 100% yield, so that's definitely going to lower the yield. And the disadvantage with this second method is that you could end up with a mixture of the secondary, the tertiary amines, and even the quaternary ammonium salt. So that would be that would be the advantages and disadvantages of the two different methods. It's just a one-off bit of information. Why I might as well do it now. What are the uses of quaternary ammonium salts? Well, quaternary ammonium salts, they tend to be, you've got nitrogen there, and it's got a positive charge on it. And say you've got 3 methyl groups there. And let's say here we've got a much longer carbon chain. So let's say that is 10 long. These molecules have detergent-like properties. Okay, this would have detergent-like properties. I think they're found in shampoo and soaps and things like that. They're quite mild detergents. And the reason why they're detergent, because you've got as quite often is the case, you have a hydrophilic head, the charged end, and you have a hydrophobic tail. So rather like a soap molecule, if you've covered that already. Okay.